another episode of Math with Mullins. Today we're going to look at 3.4 day 2, which is actually writing proofs. So day 1 we talked about algebraic reasoning, which is a great introduction to proofs. So if you haven't had a chance to watch 3.4 day 1, I would highly recommend that. That just kind of gets you going on how proofs work. It's a little bit easier and you're not having to worry about all these postulates, properties. Today though, we're going to dive into that. So we'll be able to recall and apply the following postulates, properties and definitions of proofs. We're going to look at points, lines, and planes, properties of congruence. So what is reflexive, symmetric, transitive, properties of congruence, and then what is the definition of congruence followed by the definition of midpoint. These are some postulates that we would just think about when we are talking about our pictures that we're going to notice today. So through any 2 points, there's exactly one line. That just means here is 2 points, and we can draw a line to make it happen. Through any non-collinear 3 points, there is exactly one plane. So that just means here are 3 points, not all on the same line, and they can be in the same plane. A line will contain at least 2 points. Sometimes we might have 3 points, and that's okay. A plane contains at least 3 non-collinear points. So like here, not all on the same line, just showing that extra space regarded to the plane. If 2 points lie in a plane, there's that E, then the entire line containing those points lies in that plane. And if 2 lines intersect, then their intersection is exactly 1 point. If 2 planes intersect, then their intersection is line. So these are just things that you should be aware of before we get into our lesson for today. All right, properties of congruence. Some of these are just kind of a repeat of the day before, so this is just good information. The reflexive property of congruence, it just says for any segment AB, it'll be equal to AB. Okay, so reflexive is just repeating what you saw. We can take that and talk about the symmetric property of congruence, and that just says, let's say if x is equal to y, then y is equal to x, or the measurement of x is congruent to y, then y is congruent to x. And then transitive property of congruence, that's kind of like the domino effect or law of syllogism. If A is equal to B and B is equal to C, then A can be equal to C. So make sure you have that filled in, and then we're going to talk about 2 more definitions. The definition of congruence is a way that you can provide a reasoning in your proof. So for example, if I have segment AB, I can say that's congruent to BC. Then that means AB is equal to BC. You can also use this reasoning if you are choosing the measurement of angles. So if the measurement of angle A is congruent to the measurement of angle B, then angle A is congruent or equal to angle B. Okay? The last one is a definition of a midpoint. This midpoint of a segment will divide the segment into 2 congruent equal parts. So here's a picture for us. If you need a picture, it says M is the midpoint of AB. So M would be here. So we're seeing 2 congruent segments. So AM should be congruent to MB. Okay? Make sure we have those filled in. And what we're going to do next is we're going to try some proofs. So example 1 says this. I'm given this picture over here, and it says segment KL is congruent to LN. So as I read these givens, I'm going to start to give it some symbols that I can make sure I'm tracking with that. So KL is congruent to LN, and then it says LM is congruent to LN. So that means that one is congruent as well. I want to be able to prove that L is the midpoint of KM. So what I have is I have our statements filled out for us, and we're going to figure out what reasons I can put down. So statement 1 is my given, but then statement 2 looks almost identical to that, and that is when we used the definition of congruence. So we're just saying that because they are using that congruent symbol, that means all their measurements are going to be equal or the same. Then it says KL is equal to LM. Here we can use the transitive property. Some of you can even get away with using substitution. So both of those kind of go hand in hand. So either one would work fine. And then step 4 says L is the midpoint of KM. Well, we said that KL is equal to LM, so that means L has to be the midpoint. That would be using the definition of midpoint. Okay, and then we're done. So let's move on to example 2. Maybe see if you can try this one on your own. So maybe pause the video here, try it, and when you're ready to go on, click play. Now what we're done for this one, if I've given you the reasons, we're going to try to fill in the statement. So point P is the midpoint of JK, so that means J to P is congruent to P to K. So the definition of midpoint would be exactly that. The measurement of JP is congruent to the measurement of PK. And the reason why I put these lines on top is because step 3 says the definition of congruence, so that means I can write it without it. JP is equal to PK. Then I would substitute. So JP is substituted with x, PK is substituted with 5x minus 8, and now I'm going to use my algebraic reasoning. My subtraction property means I probably subtracted 5x from both sides, so I'm going to get negative 4x equals negative 8. And then my division property means I probably divided by negative 4 here, so x is equal to 2, and that is what I'm trying to prove. Last one, we're going to put it all together here. So this one for sure, take your time, pause it, see what you can come up with on your own first, and then when you're ready to check it, click play. All right, my given statement says JK is the congruent to the measurement of KL. So I'm going to go and put some tick marks there so I can get that visual. So now I'm going to prove that y is equal to 8. I probably can go ahead and use my definition of congruence. So JK is equal to KL, and that would be my definition of congruence. You want to use this before you start plugging in some substitution and numbers. So because that is telling us those numbers will be equal to one another. So because JK is equal to KL, now I can go ahead and substitute. JK is 15 and KL is 3y minus 9. I'm going to write substitution here. You could also say transitive. Either one of those works. You don't have to give me both of them though. Transitive. Okay. Once I do that, then I'm using my algebraic reasoning. So I'm going to add 9 to both sides to get 24 is equal to 3y. That'll be my addition property of equality. And then I would divide both sides by 3, so I'm getting 8 is equal to y, so division property of equality. And then finally, to make sure it's just saying y is equal to 8, I'm going to use the symmetric property. Different than reflexive. There's not a lot of times where we use reflexive as a part of our reasoning, okay? And then that'll conclude our notes for today. So hopefully this gives you a good starting point with proofs and how to write them. 3.5 we'll start doing some more proofs, but maybe with some segment relationships, more postulates, more properties there. Thanks so much for tuning in, and we'll catch you next time. Bye.